My today's topic for the discussion is about the natures of the roots of the quadratic equations. So, before moving to the topic, let's learn what is quadratic equation. In class 10 standards, you have learned about what is quadratic equation, right? An equation of the form ax squared plus bx plus c equals to 0, where a, b and c are real numbers and a is non-zero. Because if a is going to be 0, then the equation is going to be a linear equation, not a quadratic equation. That's why we take a non-zero, right? So this is the equation written here. Yeah, ax square plus bx, where a, b and a is known as this is the quadratic equation, right? And you have also learned the factorization methods to find the roots of this quadratic equation. I hope you all remembers the methods, completing the square methods. This is not much important in this topic, but you have an idea about this topic, right? You know, root satisfies the equation. If I says if I says x is equals to t is the root of the root of this equation, then x t value satisfies this equation, that is left hand sides of this term, left hand side, this is called left hand side, and this is equals to right hand side is equals to 0, satisfies the equation that LHS is equals to RHS, right? So moving to the topic of the natures of the roots of this. Nature of roots is determined by the value of the d. Where what is d here? D we say discriminant, and d value is given by b square minus 4ac. This b square minus 4ac, right? From the quadratic equation we are using to find the discriminant of this equation, right? Coefficient. Now moving to the next part. So here it is. The solution of the quadratic equation x square plus b is given by this formula. This is a direct formula to find directly. You do not need to use the factorization method or completing the square. Just put directly the value of the b square minus 4ac in this formula, and you will get the root of your equations. This is 2 root. Don't think plus minus. This means I am writing here what this means. This means minus b plus under root d. I am writing b square minus 4acs d upon 2a, right? And next minus b plus minus under root d. This means this 2 roots. One time you take plus and other time you take subtractions, right? So you have learned this in your class 10 standard, that sum of the 2 roots of the quadratic equation is minus coefficient of x upon the coefficients of x square, and products of the roots of the quadration is given by constant term upon me coefficients of x square, right? And this is the formula you can learn for now to find the difference between the roots of the quadratic equations. This is under root discriminant upon magnitude of the a, right? Till now, I hope everything is clear to you, right? So Moving on, value of the discriminant determines the natures of the root. I tell you, right? So if my discriminant value, that is b square minus 4ac, b square minus 4ac, right? ठीक है, b square minus 4ac, if greater than 0, then my roots are real and distinct. Distinct means different. If one is 2, other is 3, not same 2, right? Unequal. If my D is a perfect square, then my roots are going to be a rational roots. Here, A, B, and C are also rational. Then we are going to get only rational roots. Otherwise, if B or C value, if B or A value is irrational, then by the quadratic formula we are going to get maybe irrational roots. But if A, B, and C are rational, then we are going to get rational roots. Same for the next part. Here A, B, C value is to be a rational values. If D is not a perfect square, like 3, 5, 7 values coming, you cannot find out the square roots of the, so my roots will be irrational roots, or you can say conjugate surds, which means if my one root is coming like this, 2 plus under root 3, root 3 is rational or irrational? Irrational. Then my second root is 2 minus under root 3, right? So these are the conjugate surds of each. If my discriminant is 0, now second case, then my roots are coming to be reals and equal. Both are going to be equal. Here distinct, here equal. If my discriminant value is less than 0, then my roots will be complex and distinct, like complex conjugate. If my one root is a plus iota b, you know what is the conjugate of, you simply put a minus in front of iota terms and up b, right? This is conjugate of a minus iota b is conjugate of this term, right? So these are the three cases you have to memorize, that if d is greater than 0, then real and distinct. If d is less than 0, then my nature of root is real and equal. And if this d is less than 0, then my root is coming out with complex and distinct, right? So moving to the question related to these concepts, here it is given. If one root of the equation x square plus px plus 12 is equals to 4, is 4, while equation x square plus px plus q has equal roots, then your mind directly goes to the second case, that is discriminant is 0. Then the value of q, we have to find the value of the, right? So what we do, it is given that 4 is the root of this equation. So we simply put the value 4 square plus p. What is 4 square? You know, 16, right? Plus 12 is equals to 0. 16 plus 12. What is 16 plus 12? 20. So I am directly writing in the next step what I have getting. 4p is equals to minus 28 by 4. What it coming out to be? minus 7, right? So this is the step. Now you get the value of the p, right? I have reached this step. Now you got the value of p, and it is given that the discriminant of the second equation is 0. Now you find the discriminant of the second equation. P square minus 4q is equals to 0. Now what is my value of p? Minus 7. And squaring it, we get 49. 49 minus 4q is equals to 0. So what is my value of q now? Q is equals to 49 divided by 4. Right? So I get the value of q. Now my question is done. So moving to the next question. So here, this we have done this question. Answer part, this is roots of the equations b minus x squared 2c minus a x plus a minus b. So we have to find the natures of the root of this equation, that is real, distinct, that is either it is equal or imaginary. So we have to tell about that. So first of all, for that we need to find out the discriminant, which is given by this. D is equals to 4c 4c minus a square minus 4b minus c, that is square of this term minus 4c or this term a, right? As comparing with the quadratic equation, right? So we get this d is equals to 4c minus a square minus 4b minus c, taking 4 common out of the bracket. 4c minus a square as it is we have written here, b minus c, a minus b. On solving we get minus ab minus b square minus ac plus bc. Here it is, this term we get it. Now next we know the identity of the a minus b square. So applying here, what we get, 4c square plus a square minus 2ac. Now from the minus ab as it is here, so minus minus plus b square, here it is. So c square plus a square we have here, minus 2ac plus b, minus 2ac plus ac, what we get, minus ac, right? We have written here, minus plus minus bc minus bc. So we are getting all the terms. Now multiply by 2 and divide by 2 this equations. Multiply each and every term by 2 and divide by 2. What we are getting, 4 divided by 2, 2, and each term 2c square, 2a square, 2b square, 2a minus b, 2. So it is come out to be a identity. You 2c square, you can write c square plus c square. Similarly for a square, so taking c square, a square, and minus 2ac, one identity. Next, similarly for the second, so you are getting this term. Here it is given that a is not equals to b, means you know that all the square term is always greater than 0, equals to 0. But here it is given that a is not equals to b, means this term is not going to be 0, this may be 0. So there is no equal to part. So your discriminant, so the nature of the root is real and distinct. That is because here your discriminant is greater than 0. So I hope you got my point and everything is clear to you, right? So thanks